The room experts leave plan has shown that, with our new $101 billion financial plan, it might take quite a while before things continue as expected. If everything unfolds as planned, the journey to Proxima B is expected to take close to 20 years. However, in a more realistic scenario, it could take a few years just to confirm the presence of any life on that planet. The ongoing examination into whether we are genuinely alone in the universe continues to be fueled by discoveries made with the assistance of the James Webb Space Telescope, JWST. This telescope has already revealed various fascinating phenomena from beyond Earth, possibly bringing us closer to answering this age-old question. Our deep human curiosity about space, combined with feelings of isolation, drives us to seek other forms of life. Despite the fact that we are merely tiny specks in the vast expanse of the universe, we may be inching closer to answers. However, are these answers what we anticipate? Or are they unsettling discoveries? Join us as we dive into the latest findings in the fields of planetary systems and exoplanets, embarking on a journey that may require us to confront truths we are not entirely ready to comprehend. In 2021, researchers made a groundbreaking advancement, possibly one of the most significant breakthroughs in the history of science, with the launch of the James Webb Space Telescope. This sparked an intriguing question about the capabilities of future technology. Could advanced telescope extensions detect artificial lighting on distant planets? For example, Proxima B, the closest known exoplanet to Earth, is located 4.25 light-years away. Proxima B is known to have a permanent day side and night side, similar to the Moon. A highly advanced civilization on Proxima B could harness energy from the day side and transfer it to the night side through photovoltaic cells that convert sunlight into power. A study by Manusvi Lingam and colleagues proposed that a vast array of solar panels could be installed on the day side, with future telescopes detecting the artificial light generated by these panels. With JWST updates, our ability to search for artificial light on planets like Proxima B has significantly expanded. The fact that JWST was able to detect such light in 2024, thanks to its enhanced capabilities, marks a revolutionary moment. It is possible that JWST has uncovered the very lights we have been searching for, potentially pushing humanity into a new era of exploration. Let's take a closer look at planets and exoplanets to understand how this discovery became a reality. Throughout recorded history, humans have contemplated the vastness of the universe, questioning who we are, where we came from, and where we are going. Despite technological advancements, these timeless questions remain as complex as ever. Some researchers argue that we are still in the early stages of understanding our place in the universe, while astronomers eagerly share the latest findings made possible by modern instruments. These tools, often overlooked by the general public, represent humanity's ongoing progress in our quest to explore the universe and find our place within it. One of the most significant advancements in this endeavor is the creation of the James Webb Space Telescope, JWST, a device with immense potential to answer some of humanity's most profound questions. JWST represents our attempt to probe the mysteries of space, seeking answers to age-old questions such as, are we alone? What is our purpose? Where are we headed? This powerful infrared telescope is actively working toward these goals. If you're wondering about Proxima B, it is sometimes referred to as Proxima Centauri B or Alpha Centauri B. This exoplanet is classified as a super-Earth and orbits an M-type star. You may not be familiar with the term super-Earth, so let's clarify. Super-Earths are planets that are larger than Earth but smaller than gas giants like Neptune or Uranus. They can be composed of rock, gas, or a combination of both. These planets vary in size, ranging from twice the mass of Earth to several times its mass. Proxima B is one of these super-Earths and, like other exoplanets, orbits outside our solar system. The first hints of exoplanets emerged in 1917, but it wasn't until 1992 that the first confirmed discovery shocked the scientific community. Another exoplanet, first detected in 1988, was officially confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets across 4,161 planetary systems, with 896 systems hosting more than one planet. Many of these exoplanets orbit M-type stars. To understand M-type stars, It is important to note that they are the smallest stars in the main sequence and are commonly known as red dwarfs. These stars are abundant in the Milky Way, but their dim light makes them difficult to detect. M-type stars have temperatures around 3000 Kelvin, which is cooler than many other stars. Proxima B's host star, Proxima Centauri, has a mass approximately 1.07 times that of Earth. Interestingly, Proxima B completes one orbit around its star in just 11.2 days, a much shorter period than Earth's 365.25-day orbit. Proxima Centauri is relatively dim, emitting only 1.6% of the Sun's total visible light output. Most of its energy is produced as infrared radiation, accounting for over 85% of its total output. Proxima B orbits its star at a distance between 0.045 and 0.056 astronomical units, which is much closer than Earth's distance from the Sun. Discovered in 2016, Proxima B has attracted significant attention for several reasons. It is the closest known exoplanet to our Sun, just 4.2 light-years away. While this may seem far, it is relatively close in the grand scale of the universe. Proxima B is part of the Alpha Centauri system, a triple-star system. Despite Proxima Centauri's dim light, the Alpha Centauri system remains one of the brightest objects in the night sky, following only Sirius and Canopus. What makes Proxima B particularly intriguing is its potential habitability. It exists within its star's habitable zone, where liquid water could exist, raising the possibility of life on the planet. This has made astronomers eager to learn more about Proxima B and other similar exoplanets. The James Webb Space Telescope plays a crucial role in this research, as it aims to achieve 4 primary objectives. 1. Studying the light from the first stars and galaxies formed after the Big Bang. 2. Investigating the formation of stars and planetary systems. 3. Understanding the development of stars and planets. 4. Exploring the origins of life. As JWST continues to study exoplanets like Proxima B, we are getting closer to achieving these ambitious goals. The search for exoplanets and extraterrestrial life is not just about answering scientific questions, it is also about satisfying humanity's deep-rooted curiosity. Throughout history, humans have been driven by an insatiable desire to explore the universe, both animate and inanimate. This curiosity led to the creation of the Search for Extraterrestrial Intelligence, SETI, an ongoing effort to detect signs of life beyond Earth. SETI is one of humanity's most ambitious undertakings, akin to a cosmic game of hide-and-seek, with our planet scanning the vast universe for any signs of intelligent life. SETI began in the 1960s when astronomer Frank Drake first detected radio signals from distant stars. Although this groundbreaking discovery did not lead to direct contact with extraterrestrials, it marked the beginning of a serious effort to detect such signals. Despite numerous challenges, the search continues. Recent technological advancements, including the capabilities of JWST, bring us closer to potential breakthroughs. As JWST continues to study exoplanets like Proxima B, there is growing optimism that we may soon find definitive evidence of extraterrestrial life. If such evidence is discovered, it would fundamentally reshape our understanding of the universe and our place within it. Life, insight, and the universe itself, regardless of whether no immediate proof of life is found. The discovery of counterfeit signals or lights from far-off planets would be significant, proposing that shrewd life would be able to be undeniably more normal than we already thought. The fervor surrounding these revelations is substantial. However, they too bring up huge issues about how humankind would respond if extraterrestrial life were confirmed. Would we approach this disclosure with logical meticulousness, regard, and interest, or would it incite dread and vulnerability? History has shown that mankind frequently responds capriciously to significant disclosures, especially those that challenge profoundly held convictions. This vulnerability brings forward moral and ethical inquiries. If we were to experience keen extraterrestrial life, what obligations would we have? What moral structure ought to guide our interactions with other living things, whether microbial or advanced? These complex inquiries will probably play a focal role in shaping our comprehension of our place in the universe as we continue to explore. As we adventure further into space, the plausibility of experiencing extraterrestrial intelligence or life presents both exciting possibilities and significant uncertainties. The disclosure of, indeed, even microbial life somewhere else would decisively change how we might interpret science, development, and the idea of life itself. It could uphold the possibility that life is a normal event in the universe, as opposed to an intriguing peculiarity. Anyway, the moral and philosophical suggestions would be tremendous. How would it be a good idea for us to approach creatures from another world? Would it be advisable for us to attempt communication, or would that present unexpected perils? The dangers of defilement, biological and social, are not paltry. If such an experience were to happen, what conventions should be laid out to ensure the well-being of the two parties? This situation of finding outsider life compels us to face troublesome inquiries about human nature and responsibility. Would our mechanical prevalence give us the right to mediate or impact extraterrestrial developments, or should we take on a policy of non-interference? The potential presence of intelligent life elsewhere moves humankind to re-evaluate its place in the universe. For centuries, people have regarded themselves as the zenith of life on Earth. However, the disclosure of extraterrestrial civilizations could break this insight, lowering us and convincing us to recognize our limits. In addition, the implications of such revelations on society would be extensive. History is full of occurrences where the discovery of new wildernesses or living things has caused social turmoil. The discovery of extraterrestrial life would likely ignite debates on political, religious, and cultural levels. Some people may be excited, others fearful, and some may indeed even dismiss the findings. States and global associations would need to cooperate to decide how to best manage this data, creating structures for collaboration, regulation, and maybe even protection. The quest for extraterrestrial life also addresses existential inquiries. What does the discovery of life beyond Earth say about our purpose? Are we simply another link in a huge, grandiose chain, or do we have a special role in the universe? These reflections wouldn't just impact scientific discourse, but would also shape art, theory, and culture. Humankind's place in the universe has long been a central theme in literature, film, and art, and the reality of extraterrestrial life would move new generations to rethink what it means to exist in a universe collaborating with other sentient creatures. On a scientific level, the quest for extraterrestrial life presents exciting possibilities for exploration. As technology advances, we are increasingly able to identify potentially habitable planets, study their environments, and investigate the chemical markers of life. Instruments like the James Webb Space Telescope permit us to detect biomarkers like oxygen, methane, or other compounds related to biological cycles. The discovery of such markers on far-off exoplanets would mark the start of a new era in scientific inquiry. By studying these exoplanets, we could gain insights into the conditions that encourage life and how life could adapt to environments vastly different from our own. The development of space exploration technology has also brought us closer to the possibility of interstellar travel. While current propulsion systems are not yet capable of reaching even the closest stars within a human lifetime, breakthroughs in fields like quantum drive or antimatter could one day make interstellar journeys possible. As we push the limits of what's possible, the dream of visiting planets like Proxima B, or even farther, becomes less a sci-fi dream and more a long-term goal. While Proxima B remains the closest exoplanet that could host life, it is far from the only one worth focusing on. Huge numbers of other exoplanets, many of which dwell within the habitable zones of their stars, have expanded the probability of finding life across the galaxy. Some scientists argue that the sheer number of potentially habitable planets suggests that life could be abundant throughout the Milky Way. If this is true, the likelihood of finding intelligent life during our lifetimes might be higher than we once believed. Anyway, the challenge lies not just in identifying these planets, but also in understanding their environments and determining if conditions are truly conducive to life as we know it. One of the most fascinating aspects of this search is the possibility that life elsewhere in the universe may not resemble anything we recognize. Earth life is carbon-based, but extraterrestrial life could use entirely different biochemical systems. Life on other planets may be based on silicon, or could even thrive in conditions we consider inhospitable, like on gas giants or moons with subsurface oceans. This broadens our understanding of science and highlights the versatility of life itself, as well as expanding the search for life. The quest for extraterrestrial intelligence continues to inspire enthusiasm and speculation. If we were to detect a signal from an advanced civilization, it wouldn't just confirm that we are not alone. It could also offer a rare opportunity to learn from a more advanced species. However, the question remains: are such civilizations out there, and if so, why haven't we received any signals? The Fermi paradox. Why, given the vastness of the universe, we haven't yet identified extraterrestrial civilizations, remains one of science's greatest mysteries. It could be that intelligent civilizations are rare, or perhaps they deliberately avoid contact with us, or that they rise and fall before we have a chance to detect them. As we move forward into the unknown, one thing is clear: the search for knowledge about extraterrestrial life is much more than a scientific endeavor. It is a journey of self-discovery. Through our pursuit of the stars, we not only seek to understand what lies beyond, but also to gain a deeper understanding of ourselves. The discovery of alien life, whether microbial or intelligent, would propel humankind to confront its position in the universe and challenge the assumptions we hold about our uniqueness. Ultimately, this quest for knowledge is part of a larger journey, an expedition to answer the questions that have always troubled us. Are we alone? And if not,